my name is Hardy. I'm a senior solution architect. I'm based out of Copenhagen. So this is my very first home turf cloud native Denmark for me. So very excited to present to you here. And thanks for coming, right? So had a really good 2 weeks. Ambition is high. The reason is we got KRO into Kubernetes special interest group. That means this is not something AWS anymore, not Google or Microsoft. This is Kubernetes. What I'm talking now is got to do nothing about our standard offerings or services or anything. I'm just talking plain Kubernetes, right? So I strongly believe that it goes without me saying that Kubernetes is a very common component when it comes to modern platform building. I think we can look into the Kubernetes design principle, and if you look back into it as to why the way Kubernetes behaves with declarative patterns, reconciliations, continuous reconciliation, the way the Kubernetes cluster behaves is very much like what you want in a developer platform. On top of it, Kubernetes is really extensible, right? If you look into it, it's a really extensible platform. And I do like that whoever created Kubernetes, the engineer sitting in there, didn't really think about solving all of the world problems, didn't try to boil the ocean, just put enough abstraction and extensibility into it and then set it free. Go figure out, right? And the way they did that is this the mechanism or this way of declaring yet another YAML called custom resource definition, CRDs, basically. So we have a very rich CNCF ecosystem today, hundreds of products, great open source project. Every one of them, by and large, are using some form of a CRD to offer their services. The way you extend Kubernetes as of today is to write CRDs, open up Kubernetes. But this comes with some challenges, right? Like not everything is for free, as in life. For the developer, there is a challenge that there is a high, steep learning curve. Understanding resources and relationship in context to the applications that they're building, right? At the end of the day, your business is building application that's your business needs. It's not there to serve YAML files on Kubernetes. Managing those resources and the application together is a struggle. And maybe not as a struggle when you just started with Kubernetes and have a few applications. When you really get to scale, hundreds of applications, probably for some of you, probably running into thousands of applications, the complexity gets really hard. And it is what we internally call in AWS. You remember those days where you had a lot of XML 8-10 years ago? Tons of XML. Today it's tons of YAML, right? So it's just that YAML complexity that you have to go through. For the platforms, you have the opposite. You have standardizations. You want to simplify, but have minimal constraints because your business still wants to add constraints on top of what's possible out of your platform, right? You want to be able to extend Kubernetes, but put it on rails, guardrails. So it's not free of everything. It can do certain things, but not all of it. Taming resource is an actual problem at enterprises. When I say taming custom resource definition is an actual problem at enterprises. Yeah. So Kubernetes is extensible. That's all well and good. We can ride on that wave. It needs a bit of specialized knowledge as to how you create something called operators, the operator pattern that's associated with custom controllers. You need to understand that. If you have a good understanding of that, that's good. You have the right skill set to start and build custom operators. You need to have ongoing investments. Every time you create something customized, you need to have investments to maintain them, nurture them, and also develop them. Often, Often what happens, what I see at enterprise is that enterprises create a custom resource definition for a particular app or a particular need, and then comes along another application, CRDB. So then they have an orchestrator on top of it that is actually massaging these two manifests. Abstractions over abstraction becomes the norm, right? When it starts with the first CRD, it's all nice and fine. When it's 2 CRD, it's still okay because it's CRD A plus CRD B. You can manage that. When you add a third CRD, it becomes either it's CRD AB or BC or AC or BC, right? This grows up. This becomes an issue. And we believe that custom controllers that don't really implement differentiated business logic, no matter how useful it is, no matter how much you're okay to bear with that technical debt, it is a technical debt, right? So how can we free people, system operators that are managing Kubernetes, of this technical debt? I think that's basically where we looked into, we need to solve this problem space. We started looking into building something like KRO. Just to give you a heads up, KRO is not the only kid in the town. There are other initiatives like Crossbane, Kubevela, that are kind of trying to solve a similar kind of a problem space. So just this, KRO is the new kid in the town, right? So when I suggest Kubernetes is endlessly customizable, let's stop the talk. Let's look at some actual working code. I need your help. Perfect. All right. I hope it's readable. It's a bit fuzzy, but I'll narrate over some of this. So when I say Kubernetes is extensible, you can run Kubernetes API resources, and you can see the different kind of Kubernetes resources it comes bundled with, right? There's some set of things in Kubernetes that's already there that you can start work with. There's the pod, the obvious one, deployment, secrets, events. These are things that you already know. And these are resources. So when I look at Kubernetes, it's basically a box with a nice little API in front, and those are resources that you can actually manipulate, you can change, you can define, on and on, right? So when I do something like kubectl get pods, I'm working on a resource called pods, right? I'm saying, hey, Kubernetes, give me this type or resource called pod within the namespace kubesystem. There's a couple of pods there, CRDs, great. Once I've spotted, zoom in, good. Is it better? Yeah. Right? Now that I know a certain deployment called CRDs exists, I can actually try and ask Kubernetes how many of those deployment type CRDs exist. It gives me CRDs, and then gives me some details if it's ready and how long ago this was instantiated. Great. What can I do? I can still pin on that resource type deployment. I can say scale up. I need more of this. I can ask it to give me 2 replicas. And once I've scaled up, I can say, hey, now I've scaled deployments, which means I know the set effectors, there'll be more pods. I can query based on pods and see how many pods there are, right? These are all types. And I can scale back down, right? Great. So what this basically means is something that we all do, 90% of us. Any requirements, any business requirements, we come down, we write an application, and compose that as a pod or a deployment, deploy it onto Kubernetes, and access it via ingress. And this works for a lot of the cases, But as your Kubernetes use case grows, as your applications grow, you need to have abstraction. You need new kinds. You need new types. Just having pods deployments works for a lot of people, but it also doesn't work for some. So what do they do? So what you can do is you can go in Kubernetes and define your own resources. Let's, for a small, short time, let's go back and think ourselves as business owner. In my case, I want to be a Pulsar One business owner. I want to start off a Pulsar One business. And I'm in a scenario where I want to be able to deploy this Pulsar One in dozens of city squares, in all transit hubs across Denmark. I have customers ordering at the stand or via delivery partners. What if each Pulsar One stand needs to act on some stock trading when the stock is low? It trades out, brings in all those bonds, bread, Pulsar, Remelil, Senep, and whatnot, right? So you have some activity going on there, and as certain things in the inventory goes up and down, you need to be able to react. You can't express all of this in a pod. For sure, you can express this as an application and wrap it in a pod, but what you can also do is you can actually create a custom resource definition. So let's take a look at that and create a custom resource definition for a Danish Pulsar One, right? So it's very simple, actually. You define the API version, the kind always has to be custom resource definition. And then you basically define the schema in which you want to interact with that particular resource. That means Kubernetes will create that endpoint for free for you, right? And once you've done that, let me just verify. Once you've done that and applied that to Kubernetes, what I can start to do is I can start to create an instance of Pulsar One, right? Here, I'm defining kind Pulsar One, and I'm saying the location is Aarhus. The preset menu is classic. The payment methods can be either mobile pay or card. And I have some admin overrides, right? I can disable the service. I can disable the service for some maintenance, cleaning, hygiene, etc. Or I can even throttle the orders, because there's a lot of activity happening. I don't have enough staff. I need to throttle the orders. So that's great. So it works for one location, that is Aarhus. And now if I want to create for the next location, which is the Banegårdspladsen, I can create the same with a little bit of override. In this case, I'm just saying for Banegårdspladsen, the capacity is a bit more. I can accommodate up to 200 people. Right? I can bring in variations here. Good. So now, this is a really cool thing for me, at least. Right? I'm not saying kubectl, give me pods, give me deployments. I'm saying kubectl, give me Pulsar One. Right? And then the nice thing is it says Banegårdspladsen Pulsar One. Right? I don't know if I applied this one. I should have two. So, yeah, there you go. I have two. All right. So far, all I've just created is some key value object and just pushed it into Kubernetes. It's a really nice key value store. It basically means nothing, right? This is where the operator pattern comes in, right? So we have a controller. A controller is something that watches the schema or the definition of provided in the YAML. Every time that something changes, it just notifies. And it also reconciles, because that's the whole point of Kubernetes, to keep continuously reconciling. And based on those triggers, you have an operator in which you can actually define your business logic. What's that business logic? Right? For example, every time somebody creates a Pulsar One, a CRD, a controller gets notified, and then the operator can use that change and actually make something useful. Maybe you have an endpoint somewhere which can connect it to Vault or Just Eat or something, and then actually make those changes in actual real system. So the operator is the glue that looks into the changes and actually makes the work, actually calls the API or the endpoint or makes the database change for those changes. So in summary, CRD defines the shape of how to interact with Kubernetes. Controller reacts and reconciles. And the operator is the brain that's actually doing something about the things that you define in the CRD. In my case, I really don't have an operator. It's just, I have the schema, which is the CRD, and not even a controller group. It's just Kubernetes doing reconcile. So, this is all nice when I'm just operating in the world of Pulsar, but I'm not just done with that. I want some live music. I want some ambiance at the house. So along with my Pulsar, I also want to have a live music stand. I also want to have a bar service. I want my Pulsar to be integrated with the delivery plans and connect to a delivery partner to do all the bookings and all that. As you can see, this is pretty much working like your product manager coming and shoving features, right? I want more. So this is basically what's happening here. And to add complexity, you probably need to operate this across multiple sites, maybe not just in Aarhus, maybe also in Copenhagen, elsewhere and elsewhere. This is how it starts in most organizations. When they start, it's very simple. 2 years down the line, the complexity is there. And this is what that means for them, right? They start writing multiple CRDs, one for Aarhus, one for Copenhagen. The explosion of CRDs slowly starts to begin, right? Every regional variation means yet another regional CRD. And then you are creating operator on top of operator to massage other operators. And this is exactly what I see at large enterprises who are venturing into CRD, right? So there's an abstraction over Hygge platform. That's what I'm aiming to build. There's an abstraction over Pulsar. There's a separate operator for live music booking, the operator for bar service. I need something to stitch them all. I don't want to have fragmented operators. I want something to be able to stitch them all together and just do this once, which means I want a Hygge platform, which includes variation of one of these kinds. And the underlying operators will create those logic. And this is exactly what KRO is trying to solve, right? And just to highlight the problem, so it's very simple when your custom resource definition is at just one CRD, no big deal, you create one bespoke operator. But as you load in more CRDs into your application stack or into your Kubernetes, the number of operators, I'm talking about the worst case here, right? That worst case scenario spikes up, right? At 5 custom CRDs, the combination of CRDs that you can do is already at 31. Imagine a place where an organization is not just running 5 CRDs, is running hundreds of CRDs. Even if it's not 100, tens of CRDs. And this is the problem KRO is trying to solve. Kubernetes is really good at being extensible. How can we build an abstraction layer into Kubernetes that makes abstraction management a little bit more sane? Let's take a look into what KRO is, right? KRO is yet another CRD by itself, right? There's no other way to extend Kubernetes. You use CRD as a way to extend. I mean, probably the other ways, the ones I know is CRD, right? So KRO comes with a spec called RGD, Resource Graph Definition. And the idea of that is that You define it like an open API spec, and then you stitch in together all the underlying CRDs that you already have within your Kubernetes. Like, deployment is one of your resource secrets or parts or anything else that you already have in Kubernetes can be one of your resource under RGD. To take this further, a CRD can also be something that's not in cluster resource. It can be a CRD that is from AWS or another cloud provider for an S3 bucket, for a Google bucket, or could be some sort of a load balancer in Azure. It can be any one of those. It doesn't need to be a CRD managed by KRO. Any CRD works. Right? Just to give you how this looks in terms of pull to own, right? I'm creating a single CRD for my Kube platform, and I've stitched up pull to own, live music booking, delivery partner booking, and bar service. So with this, what I can say now is, hey, Kubernetes, give me a Kube platform. And this is how that Kube platform should deliver a pull to own or a delivery partner booking or a live music booking. So I'm kind of defining how that Kube platform is composed and what are the variations. Right? So just to give you, it doesn't need to be pull to own, it can be any of your CRDs. And when I create those, by creating a CRD, essentially what I'm creating is an endpoint on Kubernetes. So with this, what I can ask Kubernetes is, create a Kube platform for this specific location. I can also say what I should expect as a status, right? Out there, I'm saying, pull to own ready, yes or no? Please do return when I make this API. I need to know, I need to get a feedback. Did you actually create a pull to own? Is it ready? Is the delivery partner system in sync, and is it working? So I can actually define these kind of things. So how am I doing time-wise? 10 more minutes? That's perfect. So I've just gone ahead and installed KRO. How do I install KRO? Helm. So I'm not trying to replace Helm or anything here. So Helm still exists, and for some of you who use Helm, it still is the way I install KRO. So I've done that already. So what I'm doing is I'm applying this CRD for Kube platform. So I've applied Kube platform, it gets created. That basically means now I can call Kubernetes and say, give me one instance of Kube platform. Let's look at how that looks. Oh, that failed. That really failed. And the message says, failed to build resource, live music booking. And it actually says schema not found. And that's smart from KRO, right? So it went ahead, although I arbitrarily defined all the CRDs, it went and said, you don't have the underlying defining CRDs. I'm sorry, I would like to create this API endpoint for you, but you haven't given me the dependencies. The dependency CRDs are not there. So KRO is actually underneath building a DAG, a graph, a direction graph, to see if it can actually satisfy all the requirements for you to be able to give you that endpoint. I've created the pull to own CRD, but I did not create anything for live music booking or et cetera, et cetera. And you can see this, right? You can see that when I say kubectl resource graph, get resource graph definition, it actually says the state is inactive. That means it was not able to compose the entire composition for me because I did not have the backing CRDs. So let's do that, right? Now I'm finally creating those CRDs for those backing resources that I need to create, to create a Kube platform. I've created that now. let's just give a couple of seconds for the continuous reconcile to complete, and then look into the RGD that I've just created. Come on. Let me just try one more time to see if I was... Yes. Took some time for the reconciliation to work right. I'm just running off Kubernetes on my Mac, just a mini kube cluster. Took some time. So what you see now is Kube platform. It's active. And it's actually giving me the dependency in the order. In order to create a Kube platform, I need to have a pulsar on, I need to have a live music booking, a delivery partner booking, and a bar service. And that's the order. So it was able to build a composition for me. So once I've done that, now I can go in and ask Kubernetes, I don't need pods anymore. I don't want to define deployments anymore. I want you to give me Kube platform, right? And I want that one in Aarhus. I want it on the side doc it. I want to enable music, delivery partners is Vault and good to go, and enable a bar service, right? So once I've done that, this is a really nice thing, right? So now I'm able to go into KRO and ask, what did you create? KRO created the underlining CRD that is needed for all my other custom operators. The CRD, the ones that end with doc8 delivery, that was created by KRO for me. So in the normal world, you would be creating all those doc8 delivery, doc8 music, doc8 pulsar one, all of those CRDs. What KRO is doing that is that it takes my resource graph definition and builds and backs those underlying CRDs for you. These were custom generated based on my RGD definition, based on my API call into Kubernetes. It generated that CRD. So, knowing that those custom CRDs are actually backed by an operator, you should be able to see resources created for you. And just last, just to give you a picture of how with KRO things look like. So with KRO, the platform teams are actually building instance or application stack of whatever they want to deploy. And different teams can actually go and trigger those application set and get variations of the same, whether it could be small variations within deployment, or it could also be some custom resources created elsewhere outside of Kubernetes, maybe in a different cloud. How that looks is basically something like this. So here is an example of a KRO with a CRD, with a resource graph definition to create an Amazon S3 bucket, or it could be a GCP bucket, a cross-plane PG-SQL, or it can be a set manager. Basically, it could be anything. As long as you have an operator, a business logic that can actually take those CRDs and go and make those changes in whatever place that you might want to be. So what next for KRO, right? It's baby steps. It's not production ready, as I said, right? There's a lot of happening in CRO, and there might be a lot of changes coming in as well. But we're getting a lot of feedback from the community. We're hearing a lot of good feedback that we're trying to incorporate. You're more than welcome to join. We need all the help. Join in. Where we see this CRO develop is not something that ends up being yet another tool. What we really want is Kubernetes to have a really good abstraction layer default. Not kubectl install something, something. You start with kube, and you have abstractions for you from day zero, right? If Kubernetes is that extensible and does a lot of good things really well, it should be able to have a really good abstraction layer as well from set-go. That's the ambition. Thanks for listening.